So what we were just working with was the square roots with variables, an x, a y, and n. And we saw that if you have a number, a variable, squared, and you're square rooting it, it simply becomes that variable. Simple as that. However, what happens if you don't have a squared? Let's say you have something like this, x to the third. This case, that radical doesn't cancel it quite the same. To illustrate this, let's split up this radical. Let's split up what's underneath the radical, the x to the third. X to the third, that simply means x times x times x. And now we have all these x's. We can split them up underneath their own houses. So we have the square root of x times the square root of x times the square root of x. Hey, we have a pair right here. So we take what's underneath the radical and write that just instead of the radical. So these square roots of x became just x. But notice we have the square root of x left over on the end, that third one. So we bring that down. We don't forget about him. So we bring it down and it combines. So our final answer, x square root of x. It's okay to leave one underneath there. You simplified it as much as you could. So that's as far as you can go. Let's try another example like that. Let's do square root of 16y to the fourth. Okay? So let's split it up underneath their own radicals. So the square root of 16 times the square root of y to the fourth. We know what the square root of 16 is. That's 4. Perfect square. Y to the fourth. Let's split it up into what we know y to the fourth equals. So we have the square root of y times y times y times y. Why are we doing this, Mr. Neighbor? There's 4 y's. That's why we're doing it. 4 y to the fourth, that means multiply a y 4 times. 4 y's there. Split them up underneath their own radicals now. Give them their own houses. So the square root of y, square root of y, square root of y, square root of y. Now look for your pairs. Well, we have a pair right here, and we have a pair right here. That means these two become just a y, and these two just become a y. So we have 4 times y times y. These y's can be simplified to be I'm going to write down my 4 first, and I'm going to write y squared. So here's your answer, 4y squared. That's all you have to do. Now, a few students were wondering, why do you always teach the easy problems, and why don't you give and the harder examples are always on the homework? Well, let's do some hard examples now for all of you, so you're prepared in the end. So I'm going to quickly grab my worksheet right now, and I'm going to look at square root of 60 n to the 8th. So square root of 60 n to the 8th. All right, so break it up so that we see 2 radicals. So square root of 60 times the square root of n to the 8th. Let me write that 8 a little bit better for us. Okay, so let's work with this number first, the square root of 60. Break it up into 2 things that you know. Well, I know that square root of 60, that's 4 times 15. So I'm going to write that, 4 times 15. Let's break up the square root of n to the 8th now. We know that's 8 n's multiplied together, so I'm going to write n times n times n times n times n times n times n. 1, 2, 3, 4, 5, 6, 7, 8. 8 n's multiplied together.
How's it going?
Good. So we have 8 n's multiplied together, multiplied by the square root of 4 times 15. So let's break it up underneath their own radicals. So square root of 4 times the square root of 15. And hey, we know our pair rule by now, right? So if I look at these n's and say, here's a pair, here's a pair, here's a pair, here's a pair.
Oh, I'm sorry. I'm very sorry. I was coming in early for class, but I guess you're.
Oh, what time does the class start?
Oh, not till 7:50.
Oh, okay.
Do you mind if I? No, forget it.
Okay.
Sorry about it.
So now let's split up our square root of 60. So now let's look at a harder example. The square root of 60 n to the 8th. So first, let's break it up into two separate radicals. The square root of 60 times the square root of n to the 8th. All right? Let's see what multiplies to 60. I know that 4 times 15 multiplies to 60. Maybe you thought of 2 times 30. Well, I'm going to go with 4 times 15 because I know 4 is a perfect square. So square root of 4 times square root of 15. All right, I kind of made a jump here. Instead of writing the square root of 4 times 15 underneath one radical, I split it up right away. But I'm confident you know how to do that. And now we have square root of n to the 8th. So that's 8 square roots of n. So n, square root of 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 n. So 1, 2, 3, 4, 5, 6, 7, 8. And hey, now we have to simplify by finding our pairs. So here's a pair, there's a pair, and there's a pair. We have 4 pairs of n's. That means that an n goes here from that pair, then it goes here from that pair, then it goes here from that pair, and an n goes here from that pair. Now we go back to our numbers. Can we simplify the square root of 4? Yeah, we can. We can say it's 2. What about the square root of 15? Well, that's the square root of 3 times 5, but we don't have a square root of 3 or a square root of 5 left over. So we can't form a pair. So what am I going to do? I'm just going to leave that as the square root of 15. All right. Now I just want to bring everything together. So we have 2 square roots of 15, n times n times n times n. These 4 n's multiplied together, they're simply n to the 4th. And lastly, we have to move this n to the 4th out to the front. We want to make it a little neater. So we're just going to do that. So it's 2 n to the 4th square root of 15. Okay? So we broke it up into the number and the variable underneath the radical, and we simply split everything else up. And then we found our pairs, and then worked our way down, finally rearranging so it looked nice. All right, and how about we do one more example? We're going to go through this one quick. So 4 square root 44, x to the 6th, y to the 5th. All right, so this is equal to the 4, that stays right there, we didn't touch that. The square root of 44, excuse me, I'm going to break up underneath its own radical. The square root of x to the 6th, I'm going to break underneath its own radical. And the square root of y to the 5th, I'm going to break underneath its own radical. Okay? Now, bring down that 4, I didn't touch it. Now let's look at what multiplied by what equals 44. Well, square root of 4 times the square root of 11. 4 times 11 equals 44. All right. Let's break down our square root of x. We can say that that's square root of x, 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 square root of x. 1, 2, 3, 4, 5, 6 of them. All right. And lastly, we have the square root of 5. Excuse me, the square root of y to the 5th. So I'm going to write square root of y, square root of y, square root of y, square root of y, square root, running out of room, square root of y. So there's 1, 2, 3, 4, 5 y's. 5 y's. All right, now let's look for our pairs. Here's a pair, and here's a pair. So these two square roots of x's become an x. These two also become an x. These two become an x. Now let's look at our square roots of y. Here's a pair and here's a pair. So this becomes y, this becomes y. When you have a pair, you just take the object underneath the pair without the radical. And notice, we didn't touch this last square root of y, so I have to keep him on the end. Alright, so now let's move back up to the front here. We didn't touch this 4, but the square root of 4, we know what that is. That's 2. It's a perfect square, so it's 2. And the square root of 11, we can't do anything with that. We can't simplify it at all, so I'm going to leave it as the square root of 11. Now, let's bring it all together. Let's condense it, make it closer. So 4 times 2, that's 8. Square roots of 11. X, 1, 2, 3. Then we have 2 y's. Then we have a square root of y. Alright, now let's condense these x's and y's. We can say 8 square roots of 11, that didn't change. There's 1, 2, 3 x's, so we say x to the third. 1, 2 y's, so we say y to the second. And we have a square root of y. Alright, lastly, what we're going to do, move these things to the front, and let's condense our radicals. So I'm going to move this over to the left side of the board here. So we'll have 8 square roots, Let's put out all of our solid figures out in front. So things without radicals. So 8, x cubed, y squared. Then we have the square root of 11 and the square root of y. Now what we do not want is to see 2 radicals. So what do? We combine them underneath 1. So we say 8x cubed y squared, and put these underneath the same radical, 11y. And we're finished. That's all there is to it. It's a long process. It gets a little bit difficult when you're looking at all these x's, but a trick to it is, hey, look at the exponent. If it's even, divide it by 2, and that's what your x is going to be. So here we had x to the 6, divide that 6 by 2, you get 3. There's a quick trick. If it's an odd number though, if you divide by 2, it's not going to look so pretty. 5 divided by 2 is 2.5. Notice we have y to the second, and here's another square root of y. So you can do that, but just know that you're going to have an extra y still under the square root if you do it like that, if you're working with the odds. But I encourage you to watch this video again, especially when doing the homework, to see the process. Because you have a number outside, you have a number inside the radical, and you have 2 different variables, an even exponent and an odd exponent. So there's a lot to this problem. So it's a great way to review for your homework or your quiz.